Hello, everyone. Good morning, good evening, good afternoon, good night, depending on where you are, and welcome to the Serverless Office Hours. There's been a friendly takeover. My name is Gunnar Girosh. I am a developer advocate with AWS, and you might have seen me around before as a guest on this show a few times, but now I'm hosting it this week. And I'm super excited about this episode where we're going to talk about how to build and deploy agents securely at scale using a few different frameworks and models. And to talk about that, I have my dear friend Dennis Traub joining. Hey, Dennis.
Hey, Gunnar. Hey, everyone. Good evening. For me, it's evening. For you as well, right?
It's evening for me as well.
Yeah.
We're in the same time zone. So welcome to the show, Dennis. Good to have you on.
Thanks.
And just give people a brief introduction about yourself, maybe to kick things off.
Oh God. Who am I?
Putting you on the spot.
I'm Dennis. I'm based out of Germany in the north, in the quite rainy north. It's autumn or fall, depending on where you are. I'm a developer advocate at AWS as well. I have been here for a little more than 6 years and have been focusing a lot on, well, what do you think? What have I been focusing on the last few years? AI, and specifically this year, a lot around agents. And the question that many people really have, which is how to deploy agents, how to deploy MCP servers. Everybody's talking about them, but how to actually run them in production as opposed to just on your local machine. This is what I'm working with a lot, and this is also what we're going to talk about today, I hope.
Very exciting. And as you know, if you're a viewer of this show, usually what makes this show very, very exciting is you, the viewers. Sorry, Dennis. The guests are exciting as well, but getting you as a viewer involved in this and be able to actually ask your questions, and then hopefully you can also put Dennis on the spot like I just did. And then in the end, hopefully we can reach some sort of answer. I'm sure it'll be fine. But I want to hear from you in the chat. So please let us know if you're there, where you're joining from, if it is raining and if it's evening for you as well. But welcome everyone for this episode of Serverless Office Hours. So Dennis, I think we should just jump into it straight away. And we've already mentioned a few terms, and I think we kind of need to start explaining what some of these things are. So maybe start with agents. I think that's the main thing that we hear a lot about these days.
So if you ask 3 or 5 or 10 people what an agent is, you get at least n+1 answers. But put really simply, an agent is an application that uses an LLM and tools to achieve a goal. Could be any kind of goal. Talk to a customer in a customer support situation, figure out how to help them and actually help them. But it could be something completely different. Could be you have an internal process, like you have to process data every day, and some of that data is unstructured, and there's a lot of documents that can have natural language, and you have to process that somehow. And you could have an agent to just run periodically every morning or every night and ingest the latest documents and, for instance, create summaries. So you have an application that uses an LLM, or not necessarily a large language model, could be any kind of AI, really, uses some kind of AI to achieve a goal. And one thing that's really important, and I mentioned it briefly, and we'll talk about this a lot today, is that this agent uses tools to achieve the goal. So if you look at ChatGPT, especially in the beginning in 2022 when it started, all it could do was just respond. It didn't have access to the internet. It couldn't do anything yet except responding. And especially if you asked it for current details, it actually told you, I don't have access to the internet. My cutoff date is sometime last year. I'm sorry, I can't tell you. And over time, we, as in the industry, we have started adding capabilities to the agents to use tools. And one of these tools can really just be searching the web, or reading a web page, or turning on my lights, or doing anything. So connecting the LLM to the real world. That's what tools are for. And if you have an agent and connect it to the real, or if you have an LLM and connect it to the real world, and you give it a goal to achieve, then it can do that on its own and has a certain amount of agency in that sense. And that's why we call them agents.
And we see there why it is such a broad type of term, because it encompasses so much just in that term, agents. And like you said, everyone has a definition of it right now. It's I've said this before, that it's kind of like the serverless movement back in 2018, 2019, when everyone had their definition of what serverless was. I still think we haven't exactly defined that term, though. It's still changing. So I think we'll see the same with agents over time as well.
Yeah, right. And I mean, there still are servers, right? But it's still serverless. And with agents, many people tend to say, well, they don't have real agency in the philosophical sense, which is right. But we can still call them agents because they can semi autonomously achieve goals using tools. And that's what they do. That's what I call agents.
Right, and welcome Eerie Edits, joining us from sunny LA, 9 hours from us. Welcome to the show. And also Killswitch 0007, welcome to the show as well. And we have a question there. What kind of agents are you guys building? Do you want to give an example of something you've built with agents, Dennis?
I'm currently working on a personal assistant because I've got my notebook, my paper notebook. I'm doing bullet journaling. If you don't know what that is, it's just journaling with bullets. It's just planning my day and doing things like that. I'm trying to remember stuff because my brain is old and I'm not very clever. So I have to use tools to remember things. But the problem is I never remember where I write things down, where I take my notes. I've got this notebook, but I've got tons of online note applications. We use a lot of tools at AWS to capture notes and information. And I'm constantly trying to figure out where I put something. And I'm trying to basically build a second brain in the sense of having an agent that I can just dump something, just talk to it, or send a piece of text, or send it a document, upload a document, and tell it, remember this for me. and let me know when I need it. And that's what I'm building right now. Basically, a personal assistant that I'm using for note taking, for planning things, general conversations. I've created some kind of a system prompt for the LLM because it uses an LLM internally. I've created some kind of a system prompt that it talks to me in the way that I like. It isn't overly apologetic or overly verbose. I'm overly verbose, so the agent doesn't need to be. It's really how do you say, concise in how it responds, and a little more like an actual person than like ChatGPT or other LLMs. That's what I'm building, a personal assistant, and I'm still working on it, and it still doesn't work the way I want it to.
That's very cool. So I've previously, when I've talked about serverless, I've used one of the examples that I built for myself at home is a chore tracker that I have with the kids, with the scoreboard, where they are basically doing chores, getting points, and in the end, someone wins. And I've been trying to make kind of an agent of that. So basically add the type of knowledge from LLMs to help it to do more, basically. So now we also have the agent that can tell them things to do. It can send reminders and so on as well. So in the end, I always win because I get the kids to actually do stuff at home, which is great, but they think it's fun.
Do they think it's fun?
To win, yes. When they win the scoreboard, yeah.
Well, when they win the scoreboard, but having yet another one telling them what to do in the household is like
I look like the good guy all the time because I don't have to tell them what to do. Instead, there's someone
Yeah.
else. So
Yeah, that's nice. That's a
yes.
nice idea as well. Yes.
And we have more people joining us. Hi, Piefruit. Hi, Leandro. Hi, JT2030. And hi, I might butcher this, Sumei A. And Sumei is saying that they're building a conversational AI agent designed to provide psychological support through empathetic dialogue with basic cognitive behavioral therapy technique. That's super cool. That's basically taking what you said a few steps further, Dennis, about how you actually get the LLM to respond to you. In this case, if the empathic dialogue is the very important part of that. Super cool.
I can't imagine healthcare being an area where this can be really valuable. Having I don't know where is it the I'm probably gonna butcher the name, Sume. I don't know where you're based, but here in Germany, it's really hard to get mental health counseling because there aren't enough counselors, there aren't enough therapists to. There are very long waiting lists to get counseling if you don't pay out of your own pocket. If you want to, if you pay out of your own pocket, you can certainly find someone. But if you're on a regular healthcare plan, it's really hard to find a therapist without having a very long waiting list. And I can imagine it's really interesting to provide applications that can help with maybe at least some baseline things that a therapist could provide, as long as there is no actual therapist available. I can really imagine this being helpful for many people with mental health or other psychological or psychiatric conditions.
Exactly.
I like that.
No, I think that's great. Friend of the show, Leandro, talking about building a multi-agent assistant that pulls data from multiple sources and can use a prompt like, I have 2,000 euros and I want to go to an amazing beach. And he's using AgentCore. We'll get into AgentCore in a bit. And it then suggests flights, hotels, attractions, and food that can cost a maximum of 2,000 euros. So I think that's a great use case for agents as well, where it is then able to do these multi-steps, be able to do several things that are, it's not just like you talked about initially where you're asking a question and you're getting an answer from a large language model. It's actually doing several steps to be able to achieve this.
Yeah. Right. And there's actually the last comment by Kamel Ibrahim. This is an interesting use case as well. Do you want to pull it up?
Oh, yeah.
Because when we talk about, or when most people talk about agents, they actually think of chatbots. And chatbots most of the time aren't agents. They may exhibit some agentic behavior in some cases, but most of the time people are really still thinking about chatbots. Because this is something that we can easily comprehend, right? It's like sending a WhatsApp or talking to somebody. But I think agentic AI can be really interesting in so many other use cases where you don't chat with an agent. You have it do something. You have it, as I said before, you have an LLM or some kind of an AI system that uses tools to achieve a goal. And this goal can be anything, really.
Right.
Yeah.
No. And I think this is great. We got one more here from Angel Strikes Back. Building an agent to manage personal finances. Dump all my transactions for a month in multiple banks into a folder, and it provides insights into where my money is spent and set budgets for next.
Yeah.
Using an LLM to classify and NLP on transactions.
I'm still scared of doing that. I'm still scared of doing that because of what I'm gonna find.
Yes, I guess that's it might create some trouble internally for each and everyone doing that for sure.
Yeah.
But this is cool, super exciting to hear what you're building. And hi to everyone else joining: Karti, Vivek, Manu. And Manu also has one here. I'm building a multi-agent system that takes problem statements as input and convert that into deployable CloudFormation templates, which can be deployed using CI/CD. So that's super cool. Taking the agent approach to actually creating things that are deployable in the cloud.
Nice.
Yeah. All right. So Dennis,
All right.
we talked about agents, and yeah, we could keep going for 45 minutes more talking about just what agents are and what they can do. But something else that you mentioned early on was MCP. MCP, I think, besides agents, is one of the most common things we hear as well. So what is MCP?
MCP stands for Model Context Protocol, and it's basically just a communication standard. It has evolved into a standard that defines how applications can, potentially agentic applications, or just applications that use an LLM, don't necessarily need to be agentic, can use tools using a standardized interface. It's like, and people are probably gonna hate me for saying that, but it's like REST, but not for us using websites or applications using web endpoints. It's for agents using tools. It basically defines a few so-called primitives, which is resources. So if you have documents in an S3 bucket, for example, or in a database, you can expose that as a resource to just be able to access the data without any semantics, without any interactivity, just get the information. So you can, if you have an application that just provides access to a catalog of data, of documents, you can provide access to that through MCP to an agent. The other thing, and this is what we use much more than resources, is tools. And the tools are something that can do something, whatever. It could be a web browser, it could be using a weather API to get the weather. It could be something that interfaces with your factory floor and provides data about the state of the of different machines. May provide IoT data, for instance. And this tool doesn't only provide its functionality; it also provides its description, its schema. So it tells the agent, this is how you can use me. This is what I do. So for instance, I provide state information about machines on the factory floor, and this is how you can use me. This is the specific APIs that I provide, and this is the schema, the input schema that I use. And the agent can then take this information and understand from the overall context of the goal that it's trying to achieve, understand, well, I need information about a certain machine, and I know that I have this tool available that provides information about that machine, and I can use this tool sending these arguments to get information about that particular machine. So it's basically an API definition alongside the API, just what we have done for many years with REST, for example, but in a format that's accessible for applications that use LLMs. That's MCP. Most MCP servers currently, many people really talk about MCP servers because you can just pull them into Cursor or Kiro or into your Claude application or anything. The problem there is most MCP servers aren't really servers in the sense of they run somewhere else. They are servers in a technical sense, which means your agent or your LLM basically implements a client, and then there's the server, so the two things can talk to each other. But most of the time, you take them from the internet and run them on your local machine using UVX or PipX or something like that. You take a server from the internet, download it to your local machine, and then you run it, which comes with a certain amount of risks, because you're effectively running some random code from the internet on your machine. And This is one way of using servers, and the other way of using servers, and this is what we'll look into when we get to AgentCore. The other thing is them actually being servers running somewhere else, and you can access them over the internet. You don't have to download arbitrary code. You don't have to download something where you don't really know if it really does what you want it to do or not. You can use it remotely. And AgentCore provides a mechanism, and this is why we are in the serverless office hours. Amazon Bedrock AgentCore provides mechanisms to deploy MCP servers in a serverless way. So there are servers, but they are serverless, if that makes any sense.
That makes sense. Yeah, no, and that is definitely one of the reasons why we're talking about this on the Serverless Office Hours, for sure. And if you just join us, this is the Serverless Office Hours. I'm joined by Dennis today, and we're talking about deploying agents and building agents, and we're going to look at that quite a bit. So I think it's time to jump in to things right now, Dennis. And
Yes.
let's start actually looking at some code. I know people are eager to see that.
Ooh,
so let's
code.
bring up your screen.
Oh, code. Yeah, let's bring up the screen. Let's just real quick before I show some actual code. Let me just talk about why we built AgentCore to start with. Especially with MCP servers, but also with agents, but especially with MCP servers, because many people were thinking about using MCP servers, but they wanted to deploy them somewhere. They didn't want to download them onto their local machine. They wanted to be able to use them remotely. And one of the questions we had, and many customer asked was, how do I deploy an MCP server on AWS? And there's different ways to do that. You could use a Lambda function, put an API gateway in front of it, and try to make it replicate an MCP server interface, which has certain benefits because you've got things like rate limiting. You can put a WAF in front of it. It's fairly easy to build. But the downside,
and it's something that's known. People know those services as well, which could be a benefit, of course, if you want to run your
right. But a downside is a Lambda function runs for up to 15 minutes, and some MCP provides a mechanism to maintain state between the client and the server. And so if you have a stateful connection between the client and the server, that doesn't really work with a Lambda function, because first of all, you have to keep the Lambda function running for 15 minutes. And even if it isn't used, you pay for it. And after 15 minutes, it's gone anyway. What about longer running sessions between a client and a server? And the other way to do that, to fix this problem, would be to basically use containerized MCP servers using something like ECS, maybe with Fargate, and a load balancer in front, which again which helps with the session management because it's long running, but at the same time, you have to pay for it even if it isn't used. What if you need an MCP server that is able to maintain longer sessions, but is only used once a day? So both approaches have their up and down sides, and different customers were experimenting with different of these deployment options. And we realized that we really need a way to run MCP servers and agents. It's the same with agents, because there you might also want to maintain state over time. We need to find a way for customers to be able to deploy this, having both, having long-running sessions if you need them, but only pay for the actual execution time for individual invocations. You don't have to pay for idle. And that's why we built Bedrock AgentCore, which provides exactly that. You can deploy MCP servers and you can deploy AI agents using any framework, really, without having to worry about the actual platform underneath, without having to worry about how do I manage and maintain state if I'm running it in a Lambda function where I need some kind of external state management, Or do I have to pay for the thing because it runs in a container even though I don't need it? AgentCore basically solves this problem for you.
Yeah, and us friends of serverless, we love that, of course, because as you said, even if you're running it in Lambda, that's something we know, or ECS, you still have to do a bit of that undifferentiating heavy lifting to make that MCP server work. But AgentCore then helps remove those tasks. Basically, you're back
Right.
to
Yes.
worrying about the code again, which is your
Yes.
part.
Yes.
There's a question from Leandro that I think is worth bringing up as well. You mentioned security, and the question is: are security and sandboxing boundaries something we need to evolve as a standard or framework when building MCP servers?
Well, security definitely. Sandboxing depends a bit on the actual situation. So if you want to download a standard IO MCP service, so something that runs alongside your application locally, then if you don't have the time and capacity and knowledge, you need to actually analyze the package before you use it to really be sure you know what it does. Then it really makes sense to sandbox it in some way or form to make sure it doesn't run with full permissions on your local machine. That is really important, because it could be, even if you run it inside of AgentCore, your agent may have access to resources inside of your AWS account. And if it's only MCP servers, but it has access to those, and if you download a different MCP server, which is a local process or which runs in a local process, this basically has all the permissions of your deployment. Or if you run it locally, it has all permissions on your machine and can theoretically starting to exfiltrate your .aws folder or your .ssh folder or whatever it wants to. So if you actually pull dependencies onto your machine to run them onto your machine as an MCP server, yes, you should certainly think about sandboxing. And I would really recommend not doing so with random MCP servers if you're not really sure that the source is legitimate and that you know what you're downloading. And for that, I would really recommend, even if that's the case, trying to wrap it in a server or trying to wrap it in a proxy that you can deploy as a remote server. Because in that case, you can just deploy it to AgentCore runtime. Don't give it any permissions to do anything, and just use it. And that should work.
All right. So about Bedrock AgentCore, then it consists of a few different parts. Maybe we should just quickly run through what those are. I know we're going to focus on just a few of them today, but maybe let's do an overview what they actually are.
Okay, well, let's start. Well, it's a bit, I've got this. I didn't want to show any slides. We have beautiful slides, but I don't want to show slides. I want to show code. So we have this thing here. It's a bit all over the place, but the thing is, we do have AgentCore runtime. And I already talked about this. Runtime is a way to host an agent or to host an MCP server. So if you don't already have an MCP server, or you don't already have an API that you want to expose as an MCP server, or you don't already have an agent that runs somewhere, you can deploy it directly into runtime, and that's self-contained. These are isolated environments, and actually isolated by session, and you can they are in separate instances per session, and they can't share any data unless you want them to, unless you implement something for them to share data. This is runtime. It's really a serverless hosting mechanism for agents and for MCP tools. The second thing that we have is memory, all the way on the other side. Memory basically is like a SaaS. It's not so much a deployment platform. It's more like you can use memory capabilities for your agents. They could run in runtime, but they could run anywhere else, really. But you can use memory to store conversation histories, but to also store summarized conversations and other information about conversations so that your agent can retrieve that at a later point in time. Or agents can share memory amongst each other if they work on a common task. And this is basically you don't have to use them together. You can use each of the things individually, but this is one of the ways to basically persist conversation histories, because I talked about runtime running longer than a Lambda function, but the maximum runtime of a runtime is still limited to 8 hours. So if you run the agent for more than 8 hours, the instance gets torn down, and if you invoke the same agent with the same session again, you will have a new instance, just like with a Lambda function. You will have a new instance, and memory is a way to basically persist conversation histories and conversation summaries across sessions and across different agents. That's what memory does. The third thing that we have is a few built-in tools. Right now, we do have Code Interpreter. That is something that I cannot pronounce. Code Interpreter. So that's basically a sandbox environment that allows your agent to run code. So the agent, if the agent creates code, Python code, for example, it doesn't need to run it within the agent process because, again, there's a certain risk involved. It can use Code Interpreter as a sandbox environment to run the code and just retrieve the output. And the other built-in tool that we provide via AgentCore right now is browser use. So the agent can actually use a browser to do something on the internet. Similar to memory, this can be used by any agent running anywhere. It doesn't need to be on runtime. You can just use it. It is a service that can be used on its own. Additionally, we have identity. We provide inbound and outbound auth using both OAuth, both for runtime and gateways, but also IAM-based auth, so SIG-v4 based auth. For instance, you can connect to your agent in runtime using IAM. You don't have to use OAuth. Or your agent can connect to a gateway using IAM. And this is what's managed in identity. There are a few more things. You can manage tokens and other secrets inside of identity. But this is basically what you can use for to connect to your agent or for your agent to connect to things. And then there's, of course, there's observability with CloudWatch and OpenTelemetry. The last thing that I didn't talk about really is gateways. And this is what I actually want to demo right now, because I think we've been talking for a lot of time without looking at some actual code. Gateways or Gateway, AgentCore, Bedrock AgentCore Gateway is a service that provides an interface that you can put in front of your own API to turn it into an MCP server, or that you can put in front of your existing MCP server to make it discoverable for agent. So there's two use cases, especially with MCP servers. If you just want to build one and host it somewhere, you would use AgentCore runtime. But if you already have an API and you want to be able to connect to that API using MCP as a protocol, then you would use AgentCore Gateway. And that is something that I can actually demonstrate right now.
Yeah, I think we should. So everyone, if you just joined us, this is the Serverless Office Hours. I'm Gunnar Grosch. I am joined by my friend Dennis today, and we're talking about agents and everything around agents. And we've spent 35 minutes and we haven't seen a line of code yet, Dennis. So I think it's time to pull up your IDE.
Yeah.
And let's demonstrate how we can actually use Gateway.
Yeah, let's do that. And first of all, let's answer one question. Does AgentCore have workflow control? Can you pull that up real quick on the screen? Thank you. So AgentCore by itself does not have workflow control. AgentCore especially AgentCore runtime, where you deploy your agents, is just a deployment platform, and the actual orchestration, the workflow control, happens inside of your agent, inside of the application. And if you're, for instance, use LangChain, which implements some kind of workflow control, you can have your LangChain agent do, or your LangChain workflow do all that, and you just deploy it into AgentCore. So the workflow control is managed by the actual framework, and you can use different frameworks. You can use LangChain, Llama Index. I just tested with Microsoft's new agent framework, or with Strands agents and many others. I'm currently working on implementing ADK, which works as well, but it works a bit differently if you compare it to other frameworks. But to answer the question, AgentCore itself doesn't have any opinion on how to manage workflows or what agent to use. AgentCore itself really is just a platform for you to deploy your agent into. I hope that answers the question. Let's look at some code. What I'm going to show you real quick is just an example. I was just talking about Agent Framework. This is Microsoft Agent Framework. Let's just cd into that. Cd Agent Framework, and what I'm going to run now is just a quick one-shot example that uses an actual MCP server. Let me open that up real quick. Let me go down here. And we do have all the way down. This is where I'm going to plug in an existing server URL. Let me pull that up real quick. An existing server URL is, damn it. I thought I had it.
And this is using the Microsoft Agent Framework.
This is using the Microsoft Agent Framework. Let me do something different real quick to pull up the actual URL, because I haven't written it down. Let me just run cd examples. Let me just run the example app. I'm going to show that in a second. uv run example runner py agent framework. Let's hope it works. So let's use AgentCore gateway. So this just built me the server URL, and I can quickly talk about it. When you deploy an MCP server to using Gateway, so if you use Gateway to put in front of an MCP server or in front of a Lambda function, this is what it looks like. You have a Gateway ID, then you have Gateway, Bedrock, AgentCore, the region, and so forth, and then just MCP. And that's basically the endpoint that AgentCore Gateway provides. Of course, you can put CloudFront in front of it. You can use your own domain, your own custom domain, but that's what AgentCore Gateway provides natively. Let me copy this and actually paste it into my notes. and go back real quick. Let's run the example. No, let's just add my server URL into the example and just run it before I show what it actually does.
Yep.
uv run where was it? Main, just main.py. Let's see. So it's installing a lot of stuff, which it only does once. But it's basically creating new environment right now, and it's also creating. I'm going to show you PyProject TOML. It's installing the agent framework, which is the Microsoft Agent Framework. It's also installing a library that I've written myself. It's not public yet, but I'm planning to publish it, which is an MCP client that wraps IAM calls. Mm-hmm. So that you can just use your local configuration, your local AWS configuration, to do IAM calls to an MCP server. And that's what's happening here. So it has looked at the available tools on the MCP server, and it found just one. And the tool is customer management get customer, get a customer record by ID. And then I just sent a user message, what tools are available to you. And the agent was able to respond. I have access to a single tool for customer management, yada, yada. It allows me to retrieve customer information. And this is what we actually do here. And this is really simple. Let's have a look at it. So what we use is just an OpenAI chat client. So we're using GPT-4o Mini using an OpenAI API key. So you can use any LLM. You don't have to use Bedrock. You can use any LLM. We're using an OpenAI API key here. And I'm creating an AWS MCP transport. This is from my library that I'm going to publish soon, that basically wraps the IAM call. And it creates a connection callable that it then adds to the agent framework client wrapper. So the agent framework provides something that I can connect this to, and then I can just call display available tools with the client wrapper, which shows us the tools that we have. But I can also create an agent using the agent framework chat agent, and I give it the chat client again, which is an OpenAI chat client, which uses GPT. And I just add the client wrapper, which basically contains the client, the IAM client that uses the MCP server in Gateway. And then I just return a callable, and whatever function uses this can talk to the agent. And let's go down to this real quick. This is where we actually talk to the agent. We sent the message what tools are available to you, but we can also ask, show me customer, customer 3, because it can get customer records by their ID. Let's just send this real quick. So the user message is show me customer 3, and the agent, what the agent did now was call the actual tool get customer with the ID 3, with the customer ID 3, and retrieved it. This is not an actual person. This is a dummy record, so I'm not showing any PII right now. This is just the gateway that I'm using in the background. I can really show it in AWS real quick. What's happening in the background is really just the Lambda function that where is it? This one, the gateway test function, which just, let's see. Takes a second. Here we go. All it does really is it has a bunch of customers hard-coded, and it returns the customer when the tool is called. And that's all it does. It is a Lambda function that has one job, return customers by ID. And with AgentCore Gateway, we have exposed this Lambda function as an MCP server that provides this functionality as a tool. And that's all.
This could basically be talking to some CRM system, or it could be just retrieving data from a database or something. In this example, it's just hard-coded.
Right. It's hard-coded, but it could do anything. It could retrieve data from a different API. It could retrieve data from a database or write something into a database. So what we're doing here is we have a Lambda function. We extract the tool name. We get the tool name through the context. We extract the actual tool name, and based on the tool name, if it's the one that we actually want, I'm not even testing that here because it's only providing one tool. If it's the tool that we actually want, it extracts the body from the event and then does whatever it's supposed to be doing. And this can be any kind of Lambda function, and it doesn't need to be Python, and that's very important. This Lambda function can be a C# function, or it could be a Java function, or it could be a JavaScript node function. Can be anything. This is a Lambda function that is connected through a gateway, and I'm going to show in a second how that actually works, how to connect the gateway to the Lambda function.
And right now, in your example, you said that it's using some OpenAI model to do this, and the model was, in this case, just giving all of the details for the customer. But you could basically have a prompt that's asking for specific things. So ask for the name of the customer, for instance.
Right.
And it will give you that instead.
Let's do that. And for that, I have a different application. Let me just exit real quick. And to show you, I've implemented the same thing here, examples, and that will be part of the library when I publish it. I've got examples for Microsoft Agent Framework, for LangChain. Just going to show you that real quick, which is really easy as well. This is the entire function. Right now, I'm using a chat Bedrock from LangChain with an actual Bedrock model. But again, this is all we need to connect a LangChain agent to the AWS MCP client. And the same with Llama Index, where here we go. Same thing again for Llama Index. We're using OpenAI again, but it's also using the AWS MCP client, and we're connecting our agent to this using the LLM and the tools. And the same things, obviously, with Strands, which is our own, where you also just use the MCP. You also use my library in a slightly different way, and you can just connect it to the agent using the tools. And that's it. This is just, what is it? 1, 2, 3, 4, 10, a dozen lines of code to connect any agent in any framework, basically, to MCP using AgentCore Gateway. And now let me show you the thing using my example runner, where I can really just select one of the 4 examples. Let's use LangChain now. And let's connect LangChain to the gateway as well. I've also got an MCP server running an AgentCore runtime, but we'll stick with gateway for now. So this is my URL for the gateway. Again, it loaded the available tools, but now we can actually talk to the agent. Hey, what's up? Yeah, I'm here to help, and so forth. What's the name of customer 1? The name of customer 1 is John Smith. Is that a premium customer? Oh yeah. I didn't implement memory.
Oh yeah, it doesn't have the context.
I didn't implement the agent in a way that retains the conversation history, so it doesn't. So let's is customer, what was it? 1 a premium? I'm just using a simple agent without conversation history. It's fairly easy to add that. You don't even need to use AgentCore memory for that. You can just use it, do it in memory. I'm just not doing it here. So yes, customer 1, John Smith, is a premium customer. According to the customer record, the premium member status is listed as true. So this is how I can talk to an agent that uses an MCP server in the background, and we can basically do the same thing. Let's use Llama Index this time. We can do the same thing with an MCP server that effectively does the same thing, but it's deployed to AgentCore runtime. And you can see we have a different URL. We're not using gateway this time. We're using a runtime to invoke. And it also has the get customer tool, and we can ask it, show me customer 2. And I basically deployed the same application that I deployed into the Lambda function. I also deployed it into AgentCore runtime, but in this case, it is already an MCP server. It's not just the Lambda function with a handler that is exposed as an MCP server using gateway. In runtime, it is an actual MCP server. Just using, in that case, using the standard MCP SDK from Anthropic. And here we go. That's how this works. And now, if you want, I can show you how to actually hook it up.
Yeah, let's do it.
I've been signed out. Oh, let me see. Let me sign on again using our internal thingy.
It always happens.
Yeah.
It's part of the show.
Yeah, the sessions are fairly short, which makes sense. And now let's go to Lambda. Services, AWS Lambda. And I do have a Lambda function. I have it already deployed. And all it does is I can show you in a different window when I find it. Here we go. Let's make that full screen. So the Lambda function, this is my Lambda function. It, again, has a Lambda handler, which exposes two tools. It exposes list customers, and it exposes get customer details. And effectively, it does the same thing, only in this case, I've stored a few more customers just in a JSON file. But effectively, it does the same thing as the other one. It also provides a list customers function, but that's basically it. I've deployed it using a CloudFormation template, which is here. And that's really just my Lambda function with the code. We don't even need the API gateway. I have an API gateway in front, but we don't need it because we're not using it. This Lambda function is already deployed. I'm not going to do that because that's going to take a minute or two using CloudFormation. So let's just take the one that we have. As you can see, once it's there, this is the function. It provides a list customer and a get customer details tool. And in AgentCore, let's go to AgentCore gateway. Let's create a new gateway. Let's call it customer support MCP server. And we could use JSON Web Tokens, but I'm going to use IAM permissions. I will create a new role. Let's call it, what did I call this thing? Customer support MCP server. I'll call it customer support MCP server role. And the target effectively is the following. When you send, and I can show you in the other window real quick, you saw in this one, you see these are the tool names. Mm-hmm. And because you may use different MCP servers that use the same tool names, and so that you don't have a conflict, you basically use a namespace. And that's what I'm setting here. This is the namespace. This is what this MCP this AgentCore gateway will put in front of every tool so that the agent understands, well, this is the customer management get customer tool. And the agent understands this is the thing to call and not something else that may also have a get customer endpoint. This is for conflict resolution. So we have customer support. We're going to use an actual Lambda function by ARN, which is this one. Let's just get the function ARN and add it here. I'm going to use the latest. And I'm going to define an inline schema, which I have, wait, give me a sec, which I have right here. And this schema basically just shows the list customer function, what it does, and what it actually asks for as for the input. It accepts a status, which can be active, inactive, or pending, which could be customer status. But you can also send it without a status. But if you want to get customer details, you have to send a customer ID, which is a string. And this schema is basically provided to the agent. The MCP server provides this schema to the agent, so the agent understands how to use the different tools. So I'm just gonna copy this and paste it into my inline schema editor and create the gateway. So what it's doing, it's deploying a gateway, and it's done. It's already deployed, and this gateway has a URL. Let's just copy this real quick, and I'll put it in my notes. This is the URL of the gateway that we just deployed, and this gateway has a target, the customer support. So the target is basically the Lambda function, and a gateway can have multiple targets. Could be different Lambda functions, could also be other MCP servers, or just an HTTP API somewhere on the internet. What we have here is the customer support, and it basically has all the information that we just defined. It uses a Lambda and the schema. Now, if I deploy an agent, let me deploy an agent real quick.
2 more minutes.
2 more minutes.
So very quick.
Yeah, let me deploy an agent real quick. Let's cd uv AgentCore configure. uv run AgentCore AgentCore configure. We've got it in agents, or is it strands agents main? Yeah, let's just, damn it. Okay, sorry. Agents, strands agents main. Let's call it my agent. Just really simple for now. My agent. Use the dependencies, create an execution role. An agent needs an execution role, just like a Lambda function. And I'm gonna build the agent in the cloud, so you don't have to worry about anything locally. I'm doing this, and now I can just do AgentCore launch, and this will take a few minutes. So we won't be able to see it anymore. I'll just show how it works. We run AgentCore launch. This is gonna deploy the agent now. Mm-hmm. But because we have a different agent here, we can just go ahead and use a direct URL. Let's run the example runner again. Let's run the example runner again. And let's use agent framework and use a direct MCP server URL. And for this, I'm just going to copy the URL of the gateway that we have just deployed. Okay. Hey, who's customer 5? And I hope the demo gods are, you can already see before it answers, you can already see it found 2 tools this time.
Yep.
And it found customer 5, which is Emma, which is Emma Brown.
Yep.
And if we look at that, we should be able to see that Emma Brown, is customer number 5. And that's how it works.
Very cool, Dennis. Very brief one at the end, but very cool that we got to see it actually in action. So I think we can bring down your screen share and just wrap up now. So thank you very much, Dennis, for joining us, talking about agents, MCP servers, and of course, how to use AgentCore to both deploy and be able to use your existing Lambda functions, basically, with the gateway in front of them, and then to try it all out.
Yeah.
So, Dennis,
couldn't it be serverless 2 office hours?
It should be. I think so. A couple of serverless hours, for sure. Well, Dennis, thank you so much, and thank you everyone for joining us. And Serverless Office Hours will be back next week, same time, same place. Thank you, Dennis.
Thank you. Thanks for having me. Goodbye.